Okay. Again, thanks, folks. We're recording, and I don't want to cue you out on video. Page, in your textbook, page 411. Is a summary of acids and bases. You do not have to copy what I've got on the board because I'm going to be taking it from there, but I'm going to go through it. It counts a lot of marks and it's fairly easy. Okay. First of all, they're going to ask you always, what is an acid? And there's two definitions. There's Arrhenius. He says that an acid forms H plus in water. That's an acid. Then there is a guy called Bronsted-Lowry. I may be spelling Bronsted wrong. Let's have a check. Bronsted-Lowry. That looks like two guys. Sure. Stop. So there's two guys. Bronsted and Lowry define an acid as a proton donor or H plus donor. Basically, both are saying exactly the same thing. What is an acid? Something that gives off H pluses. Both of them say the same thing. H plus. Now, according to Bronsted-Lowry, what is a base? According to Bronsted-Lowry, a base is a proton acceptor. That is according to Bronsted-Lowry. According to Arrhenius, a base forms OH minus in water. So that is slightly different. Okay? Are you with us? Go back there. Both say that an acid is a proton donor. Now, who can tell me what, in simple terms, is a proton?
Positive.
It's a positive. What is a proton? It's the positive charge of an atom. It's a hydrogen minus its electron. So what is a proton? It is simply a hydrogen minus its electron. That is a proton. So that is why all acids have got hydrogen in them, because you want to steal their electron. So let's give an example. Now, is that reaction possible? Water can go to form H plus and OH minus. Does it balance? Does this balance? So water is a acid. It's a proton donor. Did you know that water can be an acid? Now, what is this here? If that accepts the hydrogen, what is this? This is a base. OH plus H goes to form water. The reverse reaction, that is a base. Is OH a base by Arrhenius' definition? Is it a base by Arrhenius' definition? OH. Yes. Arrhenius says anything with OH is a base. Now, we have this possibility. H2O plus H2O goes to form H3O plus OH minus. Is that balanced?
Yes.
That is balanced. Does it happen in reality? Yes. Water ionizes to form hydronium ions and hydroxyl ions. Have you heard of the hydronium ion? Okay, please guys, this you need to know. Water, you don't find that protons like to sit by themselves like that. They will always attach themselves to a water and form the hydronium ion. So this is actually more closer to reality. All happy? Now, next point. Look at these. Do you see, if you look at them and you pair them off with the things that look closest to them. Look what I'm doing, Kyle. Water, H3O plus. How do these differ? Only by one hydrogen. Look at this one. Water, OH minus. How does this differ? Only by one proton or hydrogen. Now we say these are conjugate acid-base pairs. And they differ by one H plus. Now, of the two, which of these is the acid? Of this pair, which of these is the acid? Which one can donate an H plus to form the other? What do you say, Kerzia? Is that the acid or is that the acid? Which of those has donated a hydrogen in going left or right? You've got to get eyes to see this. You see, H3O plus, if it donates a proton, forms H2O. So then we say that this is an acid. And this is a conjugate base. Okay, Kerzia, let's try you now. Is that the acid or is that the acid? Which of these is going to donate an H plus? This one. Oh. Of the two, which is the one that is richer in hydrogens and H plus? Just count the number of hydrogens. This one or this one? That one. Okay, so this is your acid and that is your conjugate base. So guys, you've got to get good. Any reaction, you've got to get good at identifying the conjugate acid-base pairs. They will ask you a question like that. How do they differ? Look for the one that's got more hydrogens, that's the acid. But they always look similar. Okay, let's give you this one. H2CO3 goes to form HCO3 minus plus H plus. Which is the acid and which is the base? You look for the one that's got, they look alike, but you look for the one that's got more hydrogen. So this is similar to that, except it's got one more hydrogen. So this must be the acid and that must be the base. Now, this is carbonic acid. Let's say it reacts with NaOH goes to form Na and OH minus. Okay, that's not a good example. So let's just leave it there. Let me carry on. We'll probably pick up some more examples. Okay. So if you look on page 411, it says acid-base pairs. An acid forms its conjugate base and has donated its protons, e.g. the conjugate base of HCl is the chlorine ion. Okay? Here, HCl, Cl plus H. And it says here, the conjugate base of HCl is the chlorine ion. So the chlorine is just that minus its H. So look for the one with more H's, that's HCl. The one that looks same as it except differs by one hydrogen, that's chlorine minus. There's the conjugate acid-base pair. They differ by one hydrogen. Now, here are some of the things you need to remember. What do acids do? If I took acid and I poured it on your car, what will the acid do? Will it do anything?
Depends on the acid.
So I took some battery acid and I put it on your car. Will it damage it? Do you know that 40 years ago, the matrics basically spent their whole year memorizing an acid plus a metal forms a salt and hydrogen. Yes, the acid will eat your car and it'll produce a salt plus hydrogen gas. So here they give acid plus a metal forms a salt and water and hydrogen. What about an acid plus a base forms? What is an acid plus a base form? Sodium hydroxide and oxalic acid forms, acid plus base forms salt and water. What is the salt? Sodium oxalate in your case, your reaction. It's a salt in the balance reaction. And then an acid plus a carbonate. At the moment I've got my grade 11s, they poured vinegar on an egg. Acid, vinegar, acetic acid. Egg, calcium carbonate. Acid plus a carbonate forms three things. My matrix used to just have to memorize them. A salt, always. A water, generally. And salt, water, and carbon dioxide. So the eggshell is slowly dissolving in the... And so, do you know what? Kids did terribly because they didn't want to go and memorize these reactions. So they changed it. And so there's some examples of acid reactions on page 411 and 412. You can go and have a look at them. Then one thing they definitely are going to ask you is what's the difference between a strong acid and a weak acid? So what is the difference between a strong acid and a weak acid? Can I get rid of it? Anyone copying this down? Okay. Let's take a strong acid. Anyone think of a strong acid? And H2SO4. What do they go to form with water? They're going to form PO4 3 minus plus H plus. What's this going to form? Plus water. Look, I could put it in its simplest form. The hydrochloric acid is going to go to form, let's leave out the water just for a moment. What does it form? H plus plus Cl minus. What does that one form? H plus plus SO4 2 minus. H plus. Now, what makes that a strong acid?
Which ones?
Now, Kaylee, if I said to you, this reaction is reversible, Kaylee, and I said to you that an acid solution's got a lot of H pluses in it, and I said to you, if I want a strong acid, it must produce a lot of H pluses. So, Kaylee, I'm going to ask you, must this go strongly to the right? Must there be a big forward reaction or a small forward reaction to produce that product? To produce a lot of product, do I need a big forward reaction or a small forward reaction? Do I want this to be big and this to be small? Anyone help Kaylee out? Do you know what I'm saying at all? Do you know that reactions are reversible? And you know they can have a big to the right and a small back to the left. So this is in equilibrium, but at equilibrium it's a big one to the right. That means there's a lot of that. Now look at a weak acid, like carbonic acid. H2CO3 goes to form H plus plus HCO3 minus. Now the reaction is predominantly in that direction and a little in that direction. That's carbonic acid. Now if the reaction is primarily this way and only a little this way, will a lot of H be produced or not? Okay? A lot or a little?
A lot.
So do you see it's going to produce a lot of that, but because the arrow is pointing that direction, it's a little, see that? A little of that. That's how we work it out. So this is going to produce few H plus ions. So of the two, that with a big to the right or that with a big to the left, which is the stronger acid? The one with a big to the right. So that's a strong acid. Will this one have a big to the right, hydrochloric acid, and a small to the left? Any ideas, anyone? If it's a strong, is hydrochloric acid strong? Would you pour hydrochloric acid on your hand? No, not purposely. Therefore, go strongly to the right, only a little bit back. Now, sulfuric acid, I definitely wouldn't pour in my hand. Because sulfuric acid, a strong acid plus your flesh will eat your flesh. I don't know what's formed, but there won't be much left over. So this is strongly to the right, weakly back. What about vinegar? CH3COOH goes to form CH3COO minus plus H plus. Is vinegar strongly to the right or strongly to the left? Is it vinegar a weak acid or a strong acid?
It's a weak acid.
Okay, it's a weak acid. So it is little that way, mostly that way. You beginning to get the idea?
Yes.
So if you put a weak acid on your fish and chips, it won't eat the fish and chips. You will eat the vinegar, but it won't eat your food. If you put a strong acid on your food, it will eat your food before you get to eat it. And if you eat it, it'll eat you.
Yeah.
So that's the difference between a strong acid and a weak acid. In terms of equilibrium, I can see that you guys are not great on equilibrium. But do you remember Kc and all that stuff? Kc, the
Kc,
equilibrium constant, we put what? Products or reactants on top? What do we put on top? We put the right-hand side on top. So we would put CH3, COO minus, and H plus on top. Have you seen this before? Maybe not. This is what I try to teach online, but I don't think teaching online is that successful. Okay, so if you take vinegar, which is a liquid, it goes to form that which is aqueous and that which is aqueous. So we take the products, we put them and we multiply them together. That means the concentration of that and the concentration of that. We could put that there, the reactant CH3COOH. But what is the problem with putting this here? As I say, I think you haven't done this or you don't know. So we leave out liquids and solids. We convert a liquid or a solid just to a 1. So this becomes just that upon 1. Upon 1. We leave out anything that's a liquid or solid. Because liquids and solids can't change their concentration. And this square bracket means concentration of. And so the point that I want to make is strong acids have got a big Kc. Weak acids have got a small Kc. Strong acids have got a lot of product, little of what they start with. Weak acids have got a little product, a lot of what they start with.